come to your next topic that is actually on hydrogen. The element hydrogen is a common element. It is not actually a new thing to be studied upon. When you were still in high school, I am sure you have learned some theories or concepts related already on the element hydrogen. Hydrogen is sometimes a very popular brand, not only the other one, the oxygen, but there are also some designs that had become a popular design among t-shirts between men and women. Now, how was actually the element hydrogen found? So, this is the person responsible in the discovery of the element hydrogen. It was actually Sir Henry Cavendish, and it was discovered in London way back on the year 1766. This is the place where Sir Henry Cavendish worked with. So the gas hydrogen was actually discovered in this part of London. Now this is the main illustration of the element hydrogen. Of course, these are the general characteristics or general nature that you could get as an information about hydrogen. Hydrogen starts with the element H and it became its symbol. The atomic number is 1, the periodic number is 1, group number is 1, and group name is none. So it is very easy to locate in the periodic table where the hydrogen is. And what is unique is it does not belong to any group name. So hydrogen itself is its group. Although it belongs to the period 1 or group 1, hydrogen is independent with the other group name or group number or even period number. Since the atomic number is only 1, as you can see here, it has one electron and also has an electronic configuration of 1s1. So this is the first shell, which is actually signified as the S1. The atomic radius is 53 and then the atomic mass is 1.0079. Although in some computations, it is accepted that the atomic mass of hydrogen could be 1 gram per mole. Of course, as you have made mention, it was Sir Henry Cavendish that had discovered the element hydrogen. Okay, what are the other physical properties of hydrogen? Of course, we know that hydrogen is a gas and it is a non-metal. It has a negative 259.34 degrees centigrade melting point and also again another negative 252.87 degrees centigrade boiling point. The density, sometimes we accept the value 0, but it is not absolute 0. So this is actually the distribution of the proton and the neutron of the hydrogen. So the hydrogen atom consists the proton in the center, one proton, or in the nucleus of the hydrogen atom, and the electron traveling around the nucleus. So you have here one proton and one electron. Other physical properties of hydrogen and or dihydrogen, that is the gaseous hydrogen. The gaseous hydrogen is colorless, odorless, tasteless. Well, it is combustible, lighter than the air, and soluble in water. And hydrogen 2 or dihydrogen is has a melting point of 18.73 and 23.67 Kelvin. in terms of its boiling point. Now, if we're going to go back to our discussion, the melting point of the hydrogen gas is 13.81 in this case and 20.28 for its boiling point. Now, these are some molecular illustration to show to you the hydrogen molecule. When you will have your organic chemistry, you will gonna call this as the electron cloud formula. So this is the molecular structure of your element or your gas hydrogen. Now, where does hydrogen or the word hydrogen came from? It came from the Greek words hydro meaning water and gens meaning forming. So, hydrogen is actually a water forming element. Nearly all reactions in chemistry that involves the release of hydrogen or the accumulation of hydrogen is actually gaining and losing water electron respectively. Hydrogen is the smallest and the lightest and the most abundant element in the universe. That is a common fact that we know, although you are not yet in a higher chemistry, you have already learned that hydrogen as the first element is also the smallest, the lightest. But although it is the smallest and the lightest, it is the most abundant element in the universe, not only on Earth, in the water, but we are referring to the universe. Oxidation of hydrogen removes its electron and gives H plus or an ion hydrogen, which contains no electron and a nucleus. So this will happen if the oxidation of hydrogen will come in. It will only have one proton and its nucleus is zero or its electron is zero. So that is why hydrogen plus is often called a proton in the process of oxidation. Under the Brownstein-Lowry theory, acids are proton donors and bases are proton acceptors, both of which are possessed by hydrogen. You can see hydrogen in acids and you could also see hydrogen in bases. So a bare proton or H plus or an ion hydrogen cannot exist in solution or in ionic crystal because hydrogen is very lovable. Hydrogen is also huggable. So it reacts very rapidly with other elements. So this is the friendly element actually. So friendly. And then Uh, however, this condition is associated with the formation of plasma at high temperature. In such cases, protons cannot be removed from the electron clouds of the atom and will remain attached to them. So, maybe it is a character of hydrogen that it, it is just like human being, that there are some instances that if there are high temperatures or masyadong mainit yung temperature, there is also change in the character of a person. The same true with elements. So, if hydrogen is exposed to high temperature and it forms plasma, hardly you could get out or remove some hydrogen ions in there. So, these are the isotopes of hydrogen. There are actually several types, but the most abundant or the most common of them all are actually the first three isotopes of hydrogen. So this is the most commonly known hydrogen isotope that is available on Earth. Actually, its abundance is 99.9, nearly 100%. You could see it everywhere. So this is what we call the prosium, the ordinary hydrogen. So we have also another isotope of hydrogen. It is called heavy hydrogen. This is called the deuterium. The deuterium has one proton, but it has actually one neutron. And then we have tritium. This is a very active radioactive hydrogen. And the difference from the other two is it has two nucleus. So if you're going to illustrate here, this is the way how to write the isotope. So H is 1, the proton is 1. H is 1, but if you're going to get the total of bits, it is actually 2. The proton is 1, but if you're going to look at the neutron and the protons summation, it is actually 3. So, in terms of abundance, this is negligible as compared with the deuterium. Now, we have also another thing to consider about the prosium or the hydrogen that you know. The, the common isotope, we call it prosium, but the nucleus of this isotope contains only one single proton. Okay, since it has only a single proton, the proton has never been observed to decay, and hydrogen 1 is therefore considered a stable isotope. So, what makes an isotope stable is it does not decay, or there is no further degradation that could break its nucleus and proton, although it is possible to break. And this is a unique uh, example or unique property of hydrogen as compared with other radioactive isotopes of other elements. So we have also here a discussion on deuterium, another isotope of hydrogen. It contains one proton and one neutron as compared with protium, it has no neutron. So this is actually the illustration. So it is 2, 1, 2. And then it comprises only points, very negligible as it was made mention is 0.002 to 0.01 in terms of availability on Earth. And it is found on typical ocean water. So if you want to extract, your raw material should be coming from the seas or the ocean. That is why if you're going to make some electrolysis of water in collecting hydrogen, preferably we make use of the seawater or we add some salt in the solution of water. However, there is a great observation also of the property of deuterium in the atmosphere or in the universe. It has been enriched with respect to its initial concentration in Big Bang and the outer solar system. So its concentration in older parts of the Milky Way galaxy is also increased. The reason for this, it is due to the lower volatility of the deuterium gas and compounds. So this make deuterium fractions in comets and planets exposed to significant heat from the sun over billions of years of the solar system. Then we have this. kind of hydrogen thing, the ability of hydrogen to form the heavy water, or in the ordinary water, the formula that you know is the H2O. We are referring to the light water. But because of the presence or the action of hydrogen, there is also such thing as heavy water. And the heavy water is different from the hard water that you might have encountered. Heavy water is common name for D2O. So from deuterium reacting with oxide. The deuterium oxide or heavy water is similar with the water that you know, except that hydrogen atom in each water molecule is replaced by heavy hydrogen or deuterium. Um, the discoverer of this had earned him a Nobel Prize, but that is way, way back years, many years ago. Deuterium makes the 2O, deuterium water, 10% heavier than ordinary water. So this is the deuterium in this mixture of water. And this is deuterium and that is water. Simple experiment. Okay, we have also 3H. Um, the 3H, the other one is potassium, the other one is deuterium, and the 3H is tritium. Okay, tritium contains, sorry, I removed this. Tritium contains one proton and two neutrons in its nucleus. So from the relationship between 1 and 2 ratio, we know already that tritium is radioactive. Actually, being a radioactive, it helps in the decaying of helium-3, an isotope of helium, through beta decay with a half-life of 12.32. This is actually one way of knowing how old is a certain matter. So, if helium-3 through beta decay was able to produce its positive reaction, then that object had already earned its decaying life for 12.32 years. A small amount of tritium occurred naturally because of the interaction of cosmic rays with atmospheric gases. This is actually the lights there, the beautiful lights here are actually radioactive tritium lights. So this is one commercial product. Do not be afraid of wearing a cell phone or watch that has this property. Although it is called radioactive, the radioactive that we are might be referring to that is related to health is not that radiation that you could get from this kind of watch. So tritium has also been released during nuclear in the preparation of nuclear weapon, and it is used as thermonuclear fusion weapons, tracer and isotope geochemistry, that is very important in mining and in locating things, space under the earth. Geo means earth. So the chemistry of earth is geochemistry. So if you are looking into some elements and its isotopes, tritium is very important thing in the formation of fusion. It is specialized and self. It is used in specialized self-powered lighting devices like this one. So, what is the reaction called for? It is the D-T nuclear fusion. D-T nuclear fusion uses tritium as its main reactant. So if this is the uranium, if this is the uranium and this is your tritium, if the uranium will be able to capture this neutron of deuterium, magagalit ngayon si uranium and it will explode. It will explode and form a fission producing thermal energy. So if you are looking at the watch that you have seen just last time, and if, for example, uranium was used, but I'm sure not uranium because uranium is a very expensive element. So the hydrogen was cold, and then the uranium was cold. Sorry, the uranium will catch this low speed neutron. Bagal-bagal kasi. So nahuli siya. So since mabagal-bagal siya at nahuli niya, kontrolado na niya. Pero since kontrolado na niya, it will be able to produce energy. So emitting light as you have seen from the watch that was just last time. So we have also another, the 4H or the quadrum. So you have here the three neutrons and one proton, and this is the electron. It is actually from tritium. So the presence of hydrogen 4 or 4H is dependent upon the from the emission of protons. And the atomic mass is very interesting. It is 4. And if you're going to look at it is also very fast in terms of half-life or emitting its half-life. So the K2 neutron emission into hydrogen 3 with a half-life of 139 yoctoseconds. Now, what is yoctoseconds? Yoctoseconds is defined as the 1.39 plus minus zero point 0.1 per 10 to 22 seconds. Then we have also 5H. It is highly unstoppable isotope of hydrogen. The nucleus, if this is 3, the nucleus of 5H has 4 neutrons and 1 protons. It is also synthesized in the laboratory. It is not free in nature, just like the 4H, it is not free in nature, but it could be created by bombarding tritium with fast moving tritium nuclei. So it is really unstable. Then you have also 6H. It decays through triple neutron emission of hydrogen 3 times 3 of the tritium, or a quadruple neutron emission of the deuterium. And it has a half-life of 290 yoctoseconds as compared with 4H. Its half-life is 139 yoctoseconds. Okay, we have also 7H. It consists of a proton and six, sorry, 6 neutrons. It was just only recently done by a Russian, Japanese, and French scientists at Brikens or RIKEN RI Beam Science Laboratory. But what is used here is by bombarding hydrogen with helium-8 atom. So all six of the helium-8 neutrons were donated to hydrogen nucleus. So two remaining protons were detected by the Raman microscope. So making uh, the scientists to determine that the half-life of H7 is 23 seconds. Okay, where are the hydrogen? Hydrogen is the most abundant chemical element in the universe. That was what we were telling. And statistically, it is 75% of normal matter by mass. So you are a matter, then 75% of your normal mass is made up of hydrogen. Over 90% by number of atoms. So if you're going to make a total of all the atoms, the other 10% is not hydrogen. It is also found in abundance in stars and gas giant planets, especially the flaming ones, or the ones that we call it in a layman term as stars. The molecular cloud of hydrogen are associated with star formation. The hydrogen plays a vital role in powering stars through the proton-proton reaction and the carbon-nitrogen-oxygen cycle nuclear fusion. Every bright star in the universe or in the sky, you are sure to say that hydrogen is present in the star. Now, how is hydrogen produced? Hydrogen is normally produced by the presence of metal in an acid. We do this in the laboratory. However, the metals that are used in the laboratory are now banned by RA 6969. In the laboratory, we make use of the sodium metal with acid in order to produce hydrogen. But it was recommended by our government agencies, especially the DNR and the DOH, that, and of course the JED, that this kind of uh, laboratory activity for students is just simply generating hazardous materials or even hazardous waste. So, based from this reaction, you have here the metal and you have here the element hydrogen or the ion hydrogen, sorry. So, this could be sulfuric acid or H2SO4, this could be HCl. So, an acid HCl, upon the addition with zinc or exposed to zinc, which is a metal, will form zinc and gaseous hydrogen. Aluminum is also one metal that are usually used in the formation of hydrogen. But this takes longer reaction as compared with the zinc. Because aluminum, you can pronounce it either of the two, aluminum or aluminium. However, we are more comfortable with the word aluminum. So aluminum does not react readily with acid, so it has to be cleaned with bases first. Okay, this is just simply an illustration of metal acid for structure that we usually use in the laboratory to produce electric lights or to generate power. I am sure you know this. It is just simply looking back what you have done in high school. In 2007, that is just recently, it was discovered that an alloy of aluminum and gallium in pellets form added to water could be used commercially to generate hydrogen. So, um, along the way, it produces alumina, but the expensive gallium, which prevents the formation of oxide skin on the pellets, can be reused. So, eventually, if we're going to make a cost benefit analysis, although the gallium is more expensive, it could be used and reused as compared with the presence, the using of alumina. Because once the alumina stops reacting with the acid, then uh, it will no longer be reactive. So it is just simply a waste. This has important potential implication also of hydrogen economy. So the longer your raw material, the more hydrogen is also produced. As hydrogen can be produced on site and does not need to be transported. These are the many things that you could see as to where are the nitrogen. Sorry. Yeah, hydrogen. Sorry. So hydrogen with oxygen will give us the water. Hydrogen is also needed in the formation of ammonia needed by plant. Hydrogen is also needed in the production of fuel. Hydrogen is also needed in the formation of energy because this is added in the fuel cell, and this is the same true in the making of panels for your solar energy. This is an example of a factory producing hydrogen at commercial scale. It entails a big lot, and this is the prescribed situation because to prevent injury by the neighboring community. I think I have discussed that. Then there are modern thermochemical cycles which can be used for water splitting with the use of hydrogen. So you have the iron oxide cycle, the cerium oxide, oxide cycle. So you can use both the cerium 4 and the cerium 3 in the thermochemical cycles for producing hydrogen. You can use also the zinc oxide cycle, the sulfur iodine cycle, copper chlorine cycle, hybrid sulfur cycle. Whatever are these, you will be meeting them or be able to comprehend them when you have a higher chemistry. But in your program, BSE major in science, you will not encounter these things in your laboratory or in your course because these are actually concepts that could be understood in higher chemistry subjects, advanced chemistry subjects. Okay, these are discussions already that will lead to understanding anaerobic corrosion. Hydrogen is a very important compound present in water, and once a certain metal is exposed, especially iron, is exposed to the air or oxygen, um oxidation with the presence of hydrogen and oxygen will be very fast, and that is actually rusting of metals, especially the iron. So these are the illustrations how the rust formation could be formed. Okay, we have also geological occurrences, and we call it serpentinization reaction. That is, it refers to the absence of atmospheric oxygen. In layman's term, wala ng hangin. In deep geological conditions prevailing far away from Earth's atmosphere. So you try to imagine yung dagat or the ocean. And as you go down, uh, hydrogen is still present, but the presence of atmospheric oxygen that is needed by man in breathing will no longer be available. So the formation of metals or reactions of metals with water will vary according to the pressure or according to the light. And this anaerobic reaction of the ferrous hydroxide in contact with water at various pressure with various elements is called the Secor reaction. And the Secor reaction could only happen in the water, whereby free oxygen or atmospheric oxygen is no longer available. So we have also formation in transformers. So from all the fault gases formed in power transformer, hydrogen is the most common. And please do not try to give a direct meaning of a fault condition. A fault condition is actually the normal reaction to be produced in order to form hydrogen. So instead of forming the right product, the hydrogen make a formation, transform uh, into another life cycle. So what are your hydrogen? So hydrogen, as we have made mention, are used in the production of hydrogen, of petroleum in chemical industries. So it is used in the upgrading of fossil fuels and also likewise in the production of ammonia. You will come to learn what is ammonia later on. It is used in shielding gas in welding and also likewise in atomic hydrogen welding. So it protects the health of the welder. Hydrogen is sometimes called the forming gas, as we have made mention. So it is usually have important role in the automotive, chemical, power generation, aerospace, telecommunication industries to package leak testing. It is also used in nuclear fission application. That is well discussed because hydrogen is present in its various isotopes form. So these are the new trend or the new demands for the production of hydrogen, being a coolant and a semiconductor. So I think that ends our discussion on hydrogen. If you have any question, you can just simply type in our classroom, Google Classroom stream, or you could just simply type in our Facebook group chat. Not in the Facebook itself, but in our group chat. If you, by the way, if you think there is some people who belongs to our class but have not yet joined both the Google Class and our FB group chat, please inform them to join us. And if they are not interested, please do not persuade them because chemistry is chemistry. Sana walang napipilitan to study. If you do not have a heart for chemistry, you could hardly understand what is chemistry. But if you are willing to learn chemistry, for sure, one way or another, no matter how hard as you claim chemistry is, you will be able to learn something. And that little something might be little to you, but it's already a big thing to others. So keep on studying, study your lesson. Please stay at home so that we will be back already in our own classrooms and to stop this kind of adjustment and learning. So once again, we will continue our discussion. So we will be taking all the elements found in the periodic table as a guide in our discussion. So maybe in my next presentation, I will be discussing with you oxygen, or maybe in the within this month we will finish the important individual elements like your nitrogen, oxygen, but not carbon. Because once you start already discussing carbon, that is already about your organic chemistry. So once again, thank you for bearing this time for this discussion.